everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So, as you can see, today's topic is the construction of single-phase induction motor and pulsating magnetic field. So, let us start with this presentation. Yes, these are the topics that I am going to cover today. So what are the topics? Working principle and construction of single phase induction motor, double field revolving theory, types of single phase induction motors, and the equivalent circuit of single phase induction motor. Okay, so first of all, the what is the working principle? The single phase induction motor operation can be described by two methods. One is double revolving field theory, second one is the cross field theory. Double revolving field theory is perhaps the easier of the two explanation to understand. So let us start with the working principle of this single phase induction motor by this double revolving field theory. Okay, so what is double revolving field theory? A single phase AC current supplies the main winding that produces a pulsating magnetic field. Okay, that means in a single phase induction motor we have two types of winding. One is the main winding, second one is the auxiliary winding. So for now we are considering that in a single phase induction motor we have only the uh, uh, main winding, and in that main winding we have given a single phase AC supply, and due to that in the coil we have a pulsating generation of pulsating magnetic field. Mathematically, this pulsating magnetic field could be divided into two fields which are rotating into opposite direction. So if we draw some diagrams, so then we can very easily see that any AC quantity can be considered of the two uh, quantity AC quantity when and if they are taken into the consideration, then we can say that the total resultant will be zero, and the two opposite the two half pulsating field are working in the opposite direction. The interaction between the fields and the current induced in the rotor bar generates opposite torque. So coming to the next, the interaction between the fields and the current induced in the rotor bar generates opposing torque. Under those conditions, with only the main field energized, the motor will not start. That means the say we have a total flux of phi m. Now we are thinking of that phi m has a two component, phi m by 2 and phi m by 2. So and this phi m by 2 and the two components phi m by 2 and phi m by 2 both has opposite direction. So it has opposite direction means whatever torque is produced due to that flux, it both has the opposite direction. That means one torque is producing like this and one torque is producing like this. So what it has, what is the opposite direction? So what is the resultant? Resultant is zero. So that's why the single phase induction motor is not self starting. However, an external torque can be given to the motor so that the motor can be started. In general case, what we do, uh, we use a capacitor to provide the initial torque, so that the motor can start. Actually what we do, say think like this way, that we have a two torque for the two fluxes that and both has opposite direction, correct? Now think that within that two torque, if I am adding some torque within with any one of that two torque, then what will happen? So within that two torque, one torque will be higher and one torque will be lower. So what will be the resultant? The resultant will be the difference between the torque value of that two, and that difference, due to that difference value torque, the motor will start rotating at a higher torque direction, correct? So that thing is happening here. That is the purpose of using the capacitor. except this capacitor, we have a shaded pole methods also. So there are different methods by which we can start the single phase induction motor. So the double revolving field theory is basically is that when to single phase supply is given to the induction motor, we can think of that sinusoidal component as can be divided into two parts, and that two part is acting in the two opposite direction, and the total resultant we can find out that the total resultant is going to be 0. So the whatever torque is produced for the both two half sinusoidal component, that has a equal magnitude but opposite direction torque, so the total resultant is going to be 0. That's why the motor is not going to be start. Okay, so the pulsating field is divided so we can say that whatever I am telling that is discussing over here, the pulsating field is divided a forward and reverse rotating field. Okay, so we can think of that there are two rotating field. So two rotating field. One is rotating in the clockwise direction. One is rotating in the anti-clockwise direction. So two different fields are there, and two different fields have different. So say this is the forward rotating field, and this is the backward rotating field. Okay. So motor is started in the direction of forward rotating field. Mm, these generate small positive slip. So for that case, so for the forward field path, what is the slip value? So we know the slip value is given by ns minus nr by ns. Okay, so reverse rotating or backward rotating field generates a larger negative slip that is equal to, actually what we are doing in this ns plus nr by ns. So now the point is that we know that the slip formula is given by ns minus of nr, but why there is a plus? So actually the formula is becoming like this way as the direction is reverse. So that's why the formula is becoming ns minus in first bracket minus of nr by um, ns. So that's why minus minus there is a plus. So ns minus plus nr by ns. So these are the two slips we have, forward and reverse slip we can think of. Now from there we can say that that's why there is a neutralization of the slip. So the result is going to be 0. So that's why external force we have to give. So now one thing we can do, one thing we have seen also in sometimes we train, we have seen that whatever EMU trains we used to uh, we use in our daily life, that is um, sometimes we have seen that some fans after switching on the fans are not rotating. So at that time what we do, what we using some comb or using some pen, what we do, we give some mechanical force to that, and due to that that fan starts rotating. That means what, there is a generation of pulsating torque. So that's why the rotor is unable to rotate. So once it's trying to rotate in this direction, and in the second half of the sinusoidal waveform it is trying to rotate in this direction, but it is not so fast to act like this way. So it doesn't has any unidirectional rotation. So so what will happen, the fan is not starting. So then what we are what we do, is using some comb or pen, we give some initial torque to the induction motor, and we make within two torque, one torque higher. So in that particular direction the single phase induction motor starts rotating. So this is basically the pulsating magnetic field, double revolving field theory, whatever we can say. Now we are coming to the constructional part of single phase induction motor. So as you can see over here, construction of a single phase induction motor is similar to three phase squirrel cage induction motor. The rotor used here is same as that used in the three phase squirrel cage induction motor, and it is very simple in design, robust, and in construction. The rotor is not insulated from the core. The slots on rotor are either semi-closed type or totally closed type. The rotor windings are perfectly symmetrical and short-circuited with each other. An uniform air gap is there in in the between the stator and rotor. So when we have done in the previous semester in electrical machine 1, we have the three-phase induction chapter. So there we have seen that. So in the three-phase induction motor we have two parts. One is the stationary part, one is the rotating part. So that stationary part is known as the stator, and rotating part is known, we know that there is a rotor. So rotor can be of two type in case of three-phase induction motor. One is a squirrel cage and second one is a slip ring. So in case of squirrel cage, we know that the end terminals are shorted. So we cannot vary the extra. We cannot add extra or external any rheostat to that system. So the squirrel cage can be used for the fixed speed. So after that, if we want to change the squirrel cage induction motor speed, so what we have to do, what in the line we have to connect some rheostat, so that whatever current or voltage or power is coming to the motor, so that can be controlled. If that can be controlled, that then the motor speed can be varied. Okay, so here also in single phase induction motor, that same kind of squirrel cage rotor we are using, and over the stator we have a winding. Okay, and over the rotor we have a winding, and and uh, and that construction is used in the single phase induction motors also. Okay, and in the stator section we have a main winding, and there is a auxiliary winding is also there. So single phase induction motor can be wound for any even number of poles, that is 2, 4, 6. Obviously we know that this type of motor normally have two stator winding. In motors that operate with both windings energized, so that means we are thinking of in the stator section we have two kinds of winding. Okay, so let us see what are the windings. Acha. In motors they in motors that operate with both windings energized, the winding with more turns is known as main winding, and the other one is called the auxiliary winding. So what is the purpose of auxiliary winding, that we have to understand, because that thing is very important. Because that auxiliary winding is basically used to provide the initial torque to the system, and after the starting of this induction motor, it cuts out from the system actually. In case of this motor, synchronous speed equation is ns is equal to 128 by p, also applicable like the three-phase induction motor. This is mainly because the pole has opposite magnitude polarity. So as we can see, these are the construction of single phase induction motor. So there we can see that here is this is the there are two diagrams. So left hand side diagram is a four pole shaded shaded pole construction. So shaded means there should be a copper band over the pole, and that is a special construction in the um, near future classes. We I am going to discuss about those things in details. So for now we are just reviewing a simple diagram of induction motor. So there we can see there are the stators, four stators are there, and there is a squirrel cage rotor inside that, and in that we have the copper bars. These are the, follow my pointer, these are the copper bars, and this is the shaded pole actually. Four shaded poles are used over here, so that it can be a this induction motor can be started. Okay, so yes, let us see that according to the method we used for the starting of a single phase induction motor, the the single phase induction motor can be classified in the following categories. What are the categories? The split phase motor or resistance start motor, capacitor start motor, capacitor start capacitor run motor, two value capacitor motor, and shaded pole motor. So let us one by one we will see what is this diagram and what are the constructional features. in a very brief manner, gist manner. Okay, so first one is the split phase motor. A split phase induction motor consists of two main parts. As you can see, that is the stator, that is the rotor. The stator is provided with single phase winding, main winding and auxiliary winding. The two windings are placed 90-degree electrical apart and are connected in parallel across the single phase AC supply. So very important point is this one, that is the two windings, main and auxiliary winding, both are placed 90-degree electrical apart and they are connected in parallel across the same single phase AC supply. Whereas the auxiliary winding has a high resistance and low reactance. Okay, this auxiliary winding has a very important property, that is it has a very high resistance and low reactance. Yes, this is the diagram for split phase induction motor. So follow my pointer. So as you can see, this is the input terminal. So this is the main winding, this is the starting winding, or it is also known as the auxiliary winding, and this is the rotor, and this is a centrifugal switch. Okay, so when we are giving supply, say if initially if this stator winding is not present, if it is not present, so due to the only presence of this main winding, there is a pulsating magnetic field generation. But when we are using say this switch is closed, initially to start this this switch is closed, we are giving supply to the single phase induction motor. So due to the effect of these two windings, main winding and starting winding, what will going to happen, so there is a torque generation. So we are splitting the phase. Okay, so there is a when we are splitting the phase, there is a torque generation, and due to torque the rotor starts rotating. And when the single phase induction motor is achieving its 70 to 80% speed of its rated value, then that centrifugal switch is cut it from the circuit automatically, and uh, we can say that when this centrifugal switch is cut from the system, see this starting winding or the auxiliary winding is disconnected from the system. So at that time, only due to this main winding, this rotor rotates. Okay, so as we can understood that the purpose of the starting winding is to start the machine only, and when once it is started, once it is almost reaching its rated value speed, then it is automatically by the centrifugal tree, it is disconnected from the circuit. Now that is next method is the capacitor start motor. So in these motors, a capacitor is connected in series with the starting winding, which takes leading current and hence produce high starting torque. The capacitor motor can be classified as capacitor start and capacitor run, two value capacitor motor. That means whatever we have discussed split phase motor, that using that concept, we how we can modify that circuit, how we can we can first react to the circuit, how we can with a very high starting torque, how we can start that machine. So those things can be achieved by using some capacitor in series with that starting or auxiliary winding. Okay, so capacitor start motor, what is the capacitor start motor? In this motor, the capacitor is connected in series with this starting winding, which takes leading current. As the capacitor is used only at start, it is rated for intermediate duty and the cost of which decreases. A relatively small AC electrolytic type capacitor is used. This motor has high starting torque, about 1.5 times of the full load torque. Okay, so this high torque is achieved by the power delivered from the capacitor. Yeah, this is the diagram. See the from the previous diagram, what is the change? Extra electrolytic capacitor is added in series with the starting winding. Okay, so initially when we have to start this induction motor, single phase induction, what we have to do? We have to close the centrifugal switch. Okay, so what will happen? So the current will enter and it will flow through this main winding and starting winding. Okay, So there will be a torque generation, unidirection torque generation, and due to that unidirection torque generation, rotor starts rotating in a particular direction. Okay, and after that, and due to the presence of this capacitor, it starts rotating with a very high torque, and it very quickly achieve its rated speed. And when it is achieving its rated speed 70 to 80%, at that time the centrifugal switch cut it from the circuit, and automatically this electrolytic capacitor and starting winding disconnected from the system, and at that time only main winding is in function. Okay, now now this is another type of starting meter where we used capacitor, we use for the starting purpose also, and a capacitor is used for the running purpose also. But what are the, why we are using a capacitor for running purpose? Okay, so let us see. In this motor there is no centrifugal switch, so the capacitor remains in the circuit and helps to improve the power factor during running condition. That means, as we have seen in the previous diagram, the centrifugal switch, when the torque, high torque is provided by the auxiliary winding and by the capacitor, then when it is reaching its rated value, the centrifugal switch cuts the capacitor and the auxiliary winding from the circuit. But in this case, particular type of motor, so it is, there is no centrifugal switch. That means it is not cut it from the system. But what is the utility? To improve the power factor under running condition. The power factor of the motor under running condition is high. The operation is also quiet and smooth. The torque under running condition is also higher than the capacitor start and split phase type motor. Okay. So this is the diagram. There, as you can see, there is no centrifugal switch. So this is all about this capacitor start, capacitor run motor. Okay, two valve capacitor type motor. So this type of motor employs two capacitor, start capacitor and run capacitor. The first capacitor is rated for short rating and is used for starting. The run capacitor is rated for continuous duty, as it is used under running condition also. Okay. A centrifugal switch is used to disconnect the start capacitor when the motor has reached its 70 to 80% of its full load speed. This motor is useful when the motor has start against heavy loads. The starting torque is about 2 to 2.5 times of its full load torque. Okay, so as we have seen in the previous capacitor start, that is 1.5 up to 1.5 of the full load torque. Here we can see that that is 2 to 2.5 times of its full load torque. So it is much higher, much more efficiency we can get from this type of motor. Okay, so this is the diagram. So as you can see that the two capacitor, one is start capacitor, one is run capacitor. So once the when the supply is given and once the centrifugal switch is closed, so what will happen? So current will enter, it will flow through the magnetizing main winding and starting winding and two capacitors. So there will be a high torque generation. Due to that, there is a rotor starts rotating very quickly and smoothly, and then when it is reached its 20 to 80% of the rated value, the start capacitor cut it out from the system by this centrifugal switch, and in the system only remaining thing is that the run capacitor is present, and start capacitor is also present, main winding is also present. So when we have a very high load, and due to that, when we need very high torque, there actually we use this kind of two value capacitor, actually we use over there. Yes, this is the last one, that is the shaded pole motor. A shaded pole motor has a stator consisting of saline poles as a squirrel cage rotor. The main winding is wound on the entire pole section. When an AC supply is given in the stator winding of the shaded pole motor, due to the shading provided on the saline pole, a rotating magnetic field is produced. That means due to the shaded over the stator section, so whatever rotating magnetic field is produced, that is rotating in nature. So this is the diagram. Okay, in the near future presentation we are going to discuss those things in very vast manner. So this is for now. Okay, so this section is the shaded pole, and so when the flux is generated, that flux, magnetic flux, is rotating in nature, and that's why in case of the shaded pole induction motor, it starts rotating. Okay, so it start rotating automatically, so there is no need of capacitor or external device to start the machine. So we can make the construction of this induction motor in such a way so that it can uh, it can produce a rotating magnetic field, so that it is a self-starting. As it in three-phase induction motor, we know that it is a self-starting machine. Why? Because it generates a rotating magnetic field. But in case of single-phase induction motor, there is a pulsating magnetic field. So to make it a rotating magnetic field, we can change the construction of that single-phase induction motor. We make the stators pole like this way, and by that thing we can make it is a we can start the single phase induction motor. So this is all for today. So in this particular class we have studied that what is the construction of single phase induction motor. So what are the different types of single phase induction motor we have, what is the working principle, what is pulsating magnetic field, double revolving field theory. So those things we have completed today. Okay, thank you.